In today's lesson, we are going to continue working with absolute value equations. We're going to extend our learning by applying the solutions to multi-step equations. We're going to review the strategies that we are thinking about when we're talking about absolute value. That is the idea that when we're looking for the absolute value, we're looking for the distance a certain number is away from zero. So we know that the absolute value of a specific distance actually has 2 points on the number line. For example, if I wanted something with the absolute value of 4, I know that there are 2 points that exist. The first point would be positive 4 because the distance between 0 and 4 is 4 units. Similarly, we know that the point negative 4 also has a distance of 4 units away from 0. So for every distance, there's always going to be 2 specific quantities on the number line that exist with that distance. And the notation that we use for absolute value is some quantity inside 2 vertical bars. The other day, we solved equations by thinking of if I have a value inside the absolute value signs, this expression right here has to equal 2 quantities that when we find the distance from 0 has to be 10. And we're thinking that if we're going to break this equation to 2 separate situations, we're asking ourselves, what must the value of this expression be in order to have a distance of 10? Well, we know that the number negative 10 on the number line has a distance of 10 from 0, and we know the number positive 10 has a distance of 10 units from 0. And we are going to set this expression equal to those 2 situations. So we have a plus 8 equals negative 10, and a plus 8 equals positive 10. So this is the idea of separating our expression into 2 separate situations. So let's go ahead and extend our learning today by solving multi-step absolute value equations. So again, we are going to first look at equations where we have everything inside the absolute value signs. And when I mean inside, I mean the quantity 3j minus 2 in this expression is inside those 2 vertical bars. If we have anything on the outside, or if we're dividing the whole expression, then we're going to use a different scenario of solving. But because we are only working with things on the inside, let's go ahead and break it up into 2 situations. We know that the number negative 7 and the number 7 both have an absolute value of 7. The distance away from 0 is 7. And we know that whatever quantity inside the absolute value sign needs to equal those 2 values. So 3j minus 2 equals negative 7, and 3j minus 2 equals positive 7. And then we're going to solve these 2 equations to get 2 solutions, 2 answers that would fit this equation. So let's go ahead and apply the inverse. We're going to add 2 to both sides. So that gives me 3j equals negative 5. Then we're going to divide both sides by 3. So for this first solution, we have j equals negative 5/3. And for this equation, we're going to add 2 to both sides. So we have 3j equals 9. And if we divide both sides by 3, we get the second solution, which is j equals 3. Now, you'll notice that one of our solutions is not a whole number, and we know that the value j, or any variable, can represent an infinite number of quantities. It doesn't have to be a perfect whole number. It could be a decimal, it could be an improper fraction. You can keep that mindset as you're trying to solve some of the examples given for classwork. The other situation that we have is what happens if there are expressions on the outside of the absolute value sign. And just to clarify things, things that are on the outside of the absolute value sign means that they exist outside the boundaries of these two vertical bars. Think of those vertical bars similar to parentheses. Parentheses are keeping those expressions inside. So we know that there's something that's happening on the outside, and that's divide by 2. We want to get rid of that division of 2 by using the inverse, which is multiplying by 2. We do this so that we can have p minus 5, the absolute value, equals 12. We can now, from here, break it up into two separate situations, because we know that the value p minus 5 must either equal negative 12 or positive 12 in order to have the distance be 12 from 0. So we know that p minus 5 equals negative 12, and we know that p minus 5 equals positive 12. And when we solve these two equations, we get one solution being p equals 17, because we're adding 5 on both sides, and the other solution being p equals negative 7. So the solution set to this equation would be negative 7, comma 17. Notice that how I'm including the solution in braces rather than parentheses. We don't want to mix the solution set with an ordered pair, which are two different notations. And now we want to take what we've learned and apply with this practice together. Again, this is a type of problem where we have things on the outside of the absolute value sign, so we need to get rid of this first. So again, we want to think of these vertical bars as parentheses. So we see this number on the outside of the absolute value bars, which means there's some multiplication happening. But we can't apply the distributive property because the absolute value signs don't have the same features as parentheses. So what we need is we need to apply the inverse to get rid of that 6. So we need to divide both sides by 6. Now we have an absolute value of h plus 2 equals 3. For this particular example, we're asking ourselves what two quantities on that number line has a distance of 3 away from 0. We know that negative 3 is 3 units from 0, and we know that positive 3 is 3 units from 0. So we set that expression inside the absolute value bars equal to those two values, and then we solve. We subtract 2 from both sides. So the first solution is h equals negative 5. And we subtract 2 from the second equation. Again, this is just applying inverse operations, and we get h equals 1. So we represent our solution set with braces, and we write our two solutions separated by a comma. So if we were to evaluate this to see if this is true, go ahead and let's substitute negative 5 in for h. What's negative 5 plus 2? Well, we know that negative 5 plus 2 is negative 3. The absolute value, or the distance away from 0 for negative 3, is positive 3. Positive 3 times 6 gives us 18. So this is a true statement. The same thing with 1. If h was 1, 1 plus 2 is 3. The absolute value of positive 3, the distance is also 3. 6 times 3 equals 18. And we have just verified that those two solutions are correct. Now, here's your turn to try a problem. Notice that this is a situation where there are values on the outside. So think of what is the inverse operation that will get rid of that 5. And once you have set the new equation with only things on the inside, you can break them up into two separate situations. Go ahead and identify the answer. Good luck.